Chi-square test or the goodness of fit test is a non-parametric test that is used to find out fitness of good test. The null hypothesis assumes that there is no significant difference. So normally when the rally drivers practice for the race on an empty track, if the calculated value of the chi-square goodness of fit test is less than the table value. Good morning and welcome to the second session in Unit 5 in Business Research Methods, where we are going to speak about the chi-square test, goodness of fit. Now, chi-square test is a very important function that I would like to mention in terms of the understanding of qualitative research altogether. Now, let's try to understand the importance of chi-square test. Chi-square test or the goodness of fit test is a non-parametric test that is used to find out the observed value of a given phenomenon is significantly different from that of the expected value. Now, many a times as a researcher, you might have asked this question to yourself, that when I am trying to do a research, I'm trying to expect some value to come out of it. But unfortunately, if I am not getting my expected value, then the research would not pick up the pace, would not give me the delivered value or delivered result altogether. So that is where I try to bring in the chi-square test, which is going to observe the difference between the expected value and the observed value. So that's why this is a non-parametric test. It's very important for all of us to know. Why? Because this will help us to find out the value of the given phenomena very easily and significantly. Followed by, in the chi-square goodness of fit test that we are talking about, the term goodness of fit is to compare the observed sample distribution with the expected probability altogether. So what we are going to do here is that the term goodness of fit, the word itself will be able to tell you that it is used to compare the sample distribution with the expected probability distribution. So what we have collected as a sample, I'm going to compare and contrast it with the expected probability value and see how good, how clear it is able to match in terms of the result altogether. Now, moving further, let me just go further to try to tell you, when I talk about this chi-square goodness of fit, we determine how well the theoretical distribution, such as normal distribution, the Poisson or the binomial distribution, fits the empirical. When I talk about the word empirical, this is more about the factor how good are we trying to match the data factors together. In the chi-square goodness of fit test, the one thing that we have to understand is the concept called as sample data. The sample data is divided into intervals, which is very important for all of us to know. Why? Because once the sample data is divided, it is able to find out how it is getting to match, then automatically we will come to know where exactly the data fits in. Now then the number points that falls into the interval are compared with the expected number of points in each interval. So at each interval, I am going to compare the result versus the expected one to see how close we are in terms of arriving at the result. So every time we are going to see that the goodness of fit is trying to match an expected value and try to give us the best result as far as possible. Now, moving further, let's try to understand the procedure for chi-square goodness of fit test altogether. There are two kinds of hypotheses that we have spoken about. One is known as the null hypothesis, the other one is known as the alternative hypothesis. Now, when I talk about the null hypothesis, it means that it has assumed all the factors equally and it believes on a general statement altogether. So when we talk about setting up of the null hypothesis altogether, we say it very clearly that the chi-square fitness of good test, the null hypothesis assumes that there is no significant difference between the observed value and the expected value altogether. So that means to assume that the expected value and the observed value has got no difference at all, and it is working exactly fine. On the other hand, when I'm talking about the alternative hypothesis altogether, there is a significant difference between the observed value and that of the null hypothesis, that is the expected value altogether. Now, why is this coming into picture? For a while, let's try to understand that whenever a researcher gets into the research ideology, we all believe that all the set of equations that have been formed are equal, are easily available, and that's how we have built the equation. But unfortunately, when you start testing the numbers and when you start finding out, you will find it on an interesting manner that they are not equal. There is a variation that is coming into picture. This variation has to be measured clearly and looked into further. Then only we will be able to get a better and a clear picture as far as possible. So I would always say on this factor that whenever you are using the chi-square fitness, goodness fit altogether, the chi-square test altogether, it has to be really important that you see that you are able to match the factors clearly so that the result is also very, very clear for us. Now, the formula for calculating comes into this picture where we say x squared is equal to O minus E whole squared divided by E, where O stands for the observed value and E stands for the expected value. So now look into the comparison that we are talking about. One side you have an observed value, the other side you have an expected value. Now this is where I would like to give an example of a race track altogether. Now, normally, when the rally drivers practice for the race on an empty track, there is an amount of expectation that comes into picture. So people believe that the car will be able to finish the race in a given time second. So that's exactly the expected value. So let's say that they might say, I will be able to finish the rally in, say, about 23 minutes. But then when I really go in the rally, the live rally, I would see that the car extends it by 24.5 minutes. So now there is a difference between the observed value and the expected value altogether. Now that is very, very important. Why? Because you will be able to understand the real value of the experiment only when you are able to observe the differences. If we just believe that all the factors that are involved in the experiment are true, are clear in nature, then that means we will not be getting the true value or the real value of the research. Many a times what people tend to do when they talk about this observed and the expected value, they believe that whatever they have seen, whatever they have heard, or whatever they have come across in form of knowledge factors are true, and that's what is they try to put it on to the research. So that is why we say that when you go for a primary research and then compare those results with the secondary research, you will be able to get a better value, a better understanding altogether. Many a times what happens is that the primary research tells you that when you go to on field, you get a different set of data rather than sitting back in a room and just finding it out of the internet, the data that has been published. So now you will be able to understand that the observed value and expected value are differing to a great extent as far as possible. So this is why we bring in the chi-square fitness, that is the goodness of fit altogether. Now moving further, the hypothesis testing. Why does it matter a lot? The hypothesis testing in chi-square goodness of fit test is the same as in other tests like t-test or in ANOVA. So when I use the word hypothesis testing, I am going to find out whether the hypothesis that is being written for the research is correct. is proper in value. Why? Because moment I write an hypothesis, my belief starts saying that I'm sticking towards a particular kind of data, a particular kind of knowledge altogether. But that is not true. Unless and until I test the hypothesis and I find out whether the data is matching, I cannot conclude it. So whenever I put in the chi-square test, I want to find out whether the hypothesis testing is matching accurately or not. So second thing is that the calculated value chi-square goodness of fit test is compared with the table value. So whatever has been recorded by the previous research or a benchmark practice altogether, I am going to compare it. Now I would also like to bring in the chi-square test for all the people who are interested in fitness. Normally, when we go to a gym, we believe that we would be able to build our body or muscles in a given short time period. But then when you actually start working out in a gym, you find out that it is not the same time that we expected. Now, for example, if I go to the gym and I believe that in next 6 months, I would be able to build up a good fit body built in with muscles. But then when I start working out, I come to understand that it takes more than 1 year to get into that expected shape. That's exactly where a chi-square goodness of fit also comes into it. The observed value and the expected value. So when there is a difference in terms of observation and expectation, you will come to know the real gap that is being found inside the research. So research will always instigate you to find out the truth, to find out the gap, and that's where the chi-square is going to come with a great help to you. Followed by, if the calculated value of chi-square goodness of fit test is greater than the table value, we will definitely reject the null hypothesis. That means there is an amount of significance, there is an amount of alteration that is coming into picture, and this is where we are going to conclude. So there is some difference between the expected value and the observed value that we have been speaking about. If the calculated value of the chi-square goodness of fit test is less than the table value, now that's a very, very simple condition, then we will accept the null hypothesis and conclude that there is no significant difference at all. But many a times, let me tell you, you will definitely get some difference, you will get some significant value than the observed value altogether. So that is why chi-square test will always try to prove null hypothesis is not true and we need to go in for an alternative hypothesis altogether. With this, I come to the end of this particular session. I hope and believe that this session was of a great help and resource to you. In the upcoming session, we will be learning more about the statistical methods that are creating an impact towards the business research. Until then, stay tuned, stay blessed, and stay enlightened forever. Thank you once again for joining me today on this wonderful session.